Okay, so here we have another problem in fluid statics. So the question asks, the average specific gravity of seawater is 1.15. So they want to know what the absolute pressure at the bottom of 3,000 meters of sea is. So what we need to know here is that, first of all, fluid pressures are measured with respect to two pressure references, and that's zero pressure and atmospheric pressure. And zero pressure is actually referencing absolute pressure. And then we have atmospheric pressure, and it relates to gauge pressure. So gauge pressure would be like finding, when you're using a pressure gauge for car tires. So you take your absolute pressure minus your atmospheric pressure. That's why we read tire pressures in a smaller number. Otherwise, if we accounted for atmospheric pressure, the number would be really large. So we're going to have to use this equation. And we know pressure, since it varies linearly with vertical depth. So the relationship between pressure and depth for an incompressible fluid is given by this equation here, P equals rho GH, where P is pressure, rho is density, G is gravity, and H is height. So what we know here, they give us specific gravity of seawater, and we can actually convert that to the density of seawater using this equation here, where specific gravity multiplied by the density of water, and that will give you the density of seawater, which is 1,150 kilograms per meter cubed. And you can use this formula for anything. So if you want to find density of mercury, you use specific gravity of mercury times density of water, and that would give you density of mercury. So once we have those, so we're going to use this formula and we're going to solve for P absolute. So here we go. P absolute is going to equal rho GH plus atmospheric pressure, which we know to be 1.01325 times 10 to the 5th pascals. And so when you plug in the density we found for seawater, gravity we know to be 9.81, and the height to be 3,000, all the units should match. We get a grand total of 3.39 times 10 to the 7 pascals.